Section 7.2 is similar polygons. So up until this point, we've talked about congruent triangles, and that was all of chapter 5. And congruent triangles are triangles that are identical twins. They're exactly the same. All corresponding angles are congruent, and all corresponding sides are congruent. Similar polygons, so we're going to expand this. It's not just going to be similar triangles, but we're going to expand it to similar polygons. Similar polygons are similar, but they're not identical twins. They're not exactly the same. So in geometry, two figures that have the same shape are called similar. So what makes them similar? If their corresponding angles are congruent, so that was also true about congruent triangles. So the corresponding angles are going to be the same. They're going to be congruent, but the corresponding side lengths are proportional. So for congruent triangles, the corresponding side lengths were congruent, but now instead of being congruent, they're just going to be proportional. So here's the symbol that we use for similar. It's a tilde, so it doesn't have the equal sign under it like the congruent symbol does. So this is polygon ABCD is similar to polygon EFGH. Now you can see that the red one is bigger than the blue one. All of the angles are going to be congruent. So here, angle A is congruent to angle E, angle B is congruent to angle F, angle C is congruent to angle G, and angle D is congruent to angle angle D is congruent to angle H. So these corresponding angles are congruent. Remember, corresponding in our similarity statement, they're still going to match up. So A matches up with E, which means that A is congruent to E. And you can also see that in the picture. So all corresponding angles are congruent, and corresponding side lengths are proportional, which means, so if you look here in the top of these ratios, so we learned about ratios in 7.1, are the four sides from our smaller polygon. And in the bottom of the ratios are the four sides from the bigger polygon. So you can see that side EF corresponds to side AB in the red polygon. So we know EF to AB, that ratio is equal to FG over BC. So FG, we can see, corresponds to side BC, and you can also see that in the picture. So those ratios are going to be the same. And then so on for the other two remaining sides. So all of these ratios are going to be equal. So again, notice all of the small polygon sides are in the top and all of the big polygon sides are in the bottom. So list all pairs of congruent angles. So you just want to match up corresponding angles. So we have angle R is congruent to angle T. Angle P is congruent to angle S. And we have angle Q is congruent to angle U. And you can also see that in your similarity statement. And then we had R is congruent to angle T, and we had P was congruent to angle S. So you can also match up your corresponding angles in the similarity statement. So write the ratios of the corresponding sides in a statement of proportionality. So again, you can use your similarity statement. So side PR corresponds to side ST. So we know PR in the big triangle corresponds to side ST in the small triangle. All right, let's match up two more sides. So we started with the big triangle and then put it over the small triangle. So side RQ in the big triangle corresponds to side TU in the small triangle. And last but not least, we have side PQ in the big triangle corresponds to side SU in the small triangle. So again, big, small, or in the top were the sides from triangle PRQ, and in the bottom were the sides from triangle STU. So notice I kept that consistent in my three ratios, but we know that these three ratios are all equal, so this is called a statement of proportionality. So check that the ratios of the corresponding sides are equal. Okay, so PR is 10, which corresponds to ST, which is 8. We want to check, is that equal to RQ over TU? So 20 over 16. Again, big over small, and then last but not least, PQ over SU. So again, big over small. So let's reduce these. A 2, we can take a 2 out of top and bottom here. So 5/4. We can take a 4 out of top and bottom here. So 5/4. And we can take a 3 out of top and bottom here. So 5/4. So yes, the ratios of the corresponding sides are equal because 5/4 equals 5/4, which equals 5/4. So what is a scale factor? It's the ratio, which is just a comparison of two numbers, of the lengths of two corresponding sides of two similar polygons. So for example, the scale factor here is just 5/4. Okay. Now, how do we know it's 5/4, not 4/5? We don't. Every problem will ask, it'll specify. It'll ask you to do one triangle over the other triangle. Or you could do this triangle over this triangle. It just depends on what they ask for. So in this case, a scale factor is 5/4. So determine whether the figures are similar. Well, there's two things we need to check first. One, are all corresponding angles congruent? Yes, X is congruent to D, Y is congruent to E, and Z is congruent to F. So all those corresponding angles are congruent. Step number 2 that we need to check, let me write that down first. So 1, all corresponding angles are congruent. Step number 2, are my corresponding sides proportional? So we need to check. 6 to 9, does that equal 12 to 18? And does that equal 8 to 12? So notice I did small over big, small over big, small over big. So in the top we can pull a 3 out of both of those. Here we can pull a 6 out of both of those, and here we can pull a 4 out of both of those. So yes, 2/3 equals 2/3, which equals 2/3, which means that my triangles are similar. So if they are similar, which they are, because all corresponding angles are congruent and all corresponding sides are proportional, we can write a similarity statement. So triangle XYZ is similar, I almost wrote congruent symbol out of habit, so similar to triangle, since we went X, Y, Z, so we went 1, 2, 3, we want to do that again. So similar to triangle D, E, F, 1, 2, 3. So D, E, F. Determine the scale factor of figure B to A. So all of these came from A and all of these came from B. So our scale factor what we found was triangle A, or figure A to figure B. But they want the scale factor of B to A. So we're just going to flip the 2/3, and that means our scale factor is 3/2. And that's just because they were specifically asking for figure B to figure A. So now they're telling me that these two triangles are similar, which means that I can set up a proportion to solve for my unknown variable here, which is x. So there's multiple different proportions that you could set up to solve for your variable. I always start with the variable. So x in the small triangle corresponds to 9, in the big triangle. So since I always start with my variable, I just identify which triangle that's from. So x is from the small triangle. Oh, why did I write big? Whoops. Sorry, x is from the small triangle and 9 is from the big triangle. So we have to keep that ratio consistent. So if we do small over big for the first ratio, we have to do small over big for the second ratio. And this is where a lot of people tend to make mistakes. So we did x over 9. So now we have to go back to our small triangle. Now, it does not matter which side you pick as long as you know both sides here. So we could pick the 10 or the 8. I'm going to pick the 10 because I like to multiply by 10 better. So 10 in the small triangle corresponds to 15 in the big triangle. And now we have a proportion, and like we learned in section 7.1, we can cross multiply to solve this proportion. So x times 15 is 15x, and that equals 9 times 10, which is 90. So divide both sides by 15 to get x, and we get x equals 6. Now that's, again, not the only correct proportion that you could set up. I am going to do every problem by starting with my variable just to stay consistent. So again, find the value of x. So I'm going to start with my variable x. So x over, well, x in the big triangle corresponds to 27 in the small triangle. So again, x came from the big triangle, 27 came from the small. So we have to go big over small equals big over small. Again, it doesn't matter which two sides you pick. I'm going to pick 20 in the big triangle. So 20 corresponds to 15 in the small triangle. So 15 times x, now we can cross multiply, is 15x. And 27 times 20 is 540. And then divide both sides by 15 to get x by itself, and we get x equals 36. And the last part of this lesson, perimeters of similar polygons. So if two polygons are similar, then their perimeters are proportional to their side lengths. So that means that whatever the scale factor is, so like we did in this example, this is also going to be the ratio of the perimeters. So here we compared A to B. So if I take the perimeter of A and compare it to the perimeter of B, I should get 2/3. So that's what this is saying. So here, if I compare, the scale factor is going to be the same as the ratio of the perimeters. So compare the scale factor to the ratio of the perimeters. So scale factor doesn't matter. We can just do big over small. So we'll do, we can pick any two sides that we want. It does not matter. So we can just pick 14. So 14 in the big triangle corresponds to 7 in the small triangle. And 14 divided by 7 is 2. And we're going to keep it as a ratio, so we're going to keep it as 2 to 1. So this is our scale factor. Okay. We could have gone small to big. I just chose big to small because they didn't specify. Oh, they did specify. They did. Triangle QPR to triangle TSU. So good, we did it right. Right, so in the top here we had triangle QPR, and in the bottom here we had triangle TSU. So we got it correct. Okay, so big to small, triangle QPR to triangle TSU, and the scale factor is 2 to 1. And now let's compare the ratio of the perimeters. So again, we want to start with the perimeter of QPR in the top. So we want to do 14 plus 18 plus 16, and we get 48 over the perimeter of triangle TSU. So 7 plus 9 is 16. 16 plus 8 is 24. So 48 to 24. Can we reduce that? Yes, 48 divided by 24 is 2, so 2 over 1. And you can see that these match. And that's exactly what this was saying, is that the scale factor is going to be the same as the ratio of the perimeters. So once you know the scale factor, you also know the ratio of the perimeters. Here's one more example where there's an x and a y. So if they ask you to find x and then ask you to find y, you're just going to set up two different proportions. So for example, x in the big compares to 8 corresponds to 8 in the small. And then we have to pick sides that we know. Since we don't know y, let's either pick the 6 and the 4 or the 9 and the 6. It really doesn't matter. So maybe let's just do 9 in the big corresponds to 6 in the small. And now we can cross multiply. So 6 times x is 6x, 9 times 8 is 72, and 72 divided by 6 is 12. So x equals 12. I just couldn't use the 15 and the y in my proportion because we don't know y yet. So that's why I chose the 9 and the 6. So now if we're trying to find y, again, I always start with my variable. So y in the small corresponds to 15 in the big. So now we're going small over big. So we have to pick two sides that we know. So maybe this time let's pick 4 in the small corresponds to 6 in the big. So we did small over big. And then we can cross multiply to solve. So 6y equals 60. And divide both sides by 6, and we get y equals 10.